I am Anil Kumar. Let me thank all the viewers and participants for making this channel a very useful one. Your contributions have really made us focus on the relevant things. I hope you are enjoying and learning from this experience. Here are 5 questions which are based on absolute functions inequalities. Absolute value is also called the modulus value, and we also call this as modulus function. These 4 questions will give you an insight of how to solve inequalities based on absolute functions and will be a good foundation for all the students going forward with higher level courses like calculus. So I hope you can see the first 4 questions. Here is the 5th one. So we'll solve them one by one. You can always pause the video, copy these questions, try them out, and then look into our approach of solving them. When I say our approach, then I've seen that we normally do it in a couple of different ways so that students all over the world can appreciate it. In different schools, different methods are being taught. So we try to follow some general methods and provide a variety as we move along. Question number 1 here is, graph the following on a number line. Absolute value of x is greater than 4. So let us say this is our number line, right? So we'll use a number line, and on a number line we are going to graph the solution. All these solutions will be rough sketches, but I hope they make sense. So now, when we are saying that the absolute value of x is greater than 4, it really means what? Let's say this is 0 for us, right? Now, absolute value means that even minus 4, when you make it absolute value, will be equal to 4, correct? So it is going away. Do you see that? So that really means that going away from 4, right? So that will be one part of it. An absolute function is an even function which is symmetric about the origin. If you take that as an idea, then you know exactly what to do, correct? So that is what it is. So from the symmetry also, you could write this as your solution. Do you see that? Now what we have learned right in the very beginning is that absolute value of minus x is also equal to absolute value of x. It is an even function. Now whenever we have an even function, it is symmetric about the y-axis. So in this case, when we're talking about a number line, it will be symmetric about the origin, right? So do you get the idea, right? So that becomes the solution of absolute value of x greater than 4 on a number line. The second one here is absolute value of x is within this interval of 3. So we are trying to understand here with the concept that when we say it is like this, that means it is within given range. So that is how you could correlate it, and therefore we will say this is something which is within, and it also includes this less than equal to means. You'll fill this up. So these open circles will be filled up, and that is how you get there. So it is from minus 3 to plus 3. Let us say this is our origin. Does it make sense to you? So greater than will be beyond, right? So if you look into this concept, you could translate it literally as beyond. So beyond 4-mile radius, you can see, right? So think about staying close to the airport, but because of noise, let us say you want to stay beyond 4 kilometers, right? So away, that's the airport for you in that case. And where you are staying, anywhere beyond this radius of 4 kilometers or 4 miles or whatever, right? So that is how you could actually think about absolute functions. Then it becomes extremely simple to sketch or get the answers, correct? Now the next one here is that we're looking for absolute value to be less than minus 1, right? So clearly absolute function is either 0 or greater than, and therefore this will be all real numbers, right? So every time this statement is going to be true. So we'll have something like this, which literally indicates that x belongs to real numbers as the solution. Is that clear to you, right? Now when I say part D is absolute value of x is greater than 0. So greater than 0 means it is not equal to 0, but otherwise all other values are good, right? So we could represent this on a number line with a whole at 0, right? So not included 0, but everything else is included. Right? So I hope that makes sense, correct? So this point here, which is 0, is not included in your solution set, but everything else on a number line is included. Clear? Now question number 2 is kind of similar, but the other way. We are saying rewrite each inequality using absolute value notation. Now value of x is in between plus and minus 3. So using this notation of modulus value or absolute value, we can say that the absolute value of x is less than 3. Correct? So that becomes your solution. But if we say that x is beyond minus 2, which is x is less than minus 2 and greater than 2, in that case we can say absolute value of x is greater than 2. Perfect. Now we are saying that absolute value of that x is not equal to 5. Right? So when I say x is not equal to 5, how am I going to write this? That is a challenging question, right? Let me put a star here and then we'll think about it and get back to this. If you get an idea, get your solution here. X belongs to real numbers. We just saw this here, so we could definitely write. We can write this as that x, absolute value of x is greater than equal to, if I say greater than equal to 0, I include this point also. So it becomes all real numbers. You get it, right? Now, here, let's try to link this with something like that. We are saying that the value of x is not equal to some number. In this case, it is 5, not 0. So how can you do it? Well, that means my absolute function has translated 5 units to the right. And so I can write this as absolute value of x minus 5 is greater than 0. Now this value is going to be 0 at 5 and we want greater than 0, and therefore that becomes the solution of this question. So I hope this connection will help you remember and think about it in a proper way. So I hope that makes sense. Perfect. Now let's move on and take question number 3. Question number 3. Graph or number line and then express each in the form of absolute value of x minus a less than b, right? Now here we have two examples. You will note that the upper and the lower bounds are different numbers in absolute terms, right? Minus 3 and 7. It is not plus and minus 3. It is not plus and minus 7, correct? Same is the case with the other example. Now, if that is the case, how should you be doing it? Well, the first part, representing them on a number line, is fairly simple. Let's do that first, right? And then we'll talk about writing this as an absolute value function, correct? So what we are trying to say here is that we have a point here which is minus 3 and a point 7. Both are not included, but everything in between is included, correct? Now in this particular case, we are taking two positive values which are 0.5 and 9.5, and both are, one is included. See, this is less than equal to 1 is filled in, but the other one is not filled in, correct? Okay, so let me write down these values here. So this one here is 0.5 and that is 9.5, right? Somewhere here will be your 0, correct? Now in this case, 0 is closer to minus 3. So let me just write here. So the first part is done, that is to graph on a number line the given inequality. Now we need to express this in the absolute notation. How do we do that? Now for that, we will actually have two different methods, right? So I'll approach algebraically. Both methods are kind of similar in a way, but the approach is very different. One, let us go with the absolute function definition. So first step will be to find the center, right? So midpoint, you can say midpoint. So the midpoint here, let's call this as the m, the midpoint will be the average value, right? So we're looking for a point which is midway between them. We're calling it a midpoint m, which is going to be the average value of these two. So that is going to be minus 3 plus 7 divided by 2, or 4 divided by 2, which is 2. So the midpoint here is 2. Then what we need to look into is how far are we from midpoint? Distance from midpoint. That is basic definition of absolute function. We now want to figure out how far are we? How much is this distance, right? So the other second step is how much distance from midpoint. Let's say distance from m of the extreme value. So for both are same, that is the midpoint. 7 minus 2 in our case is 5. So we know we are within this. So the concept here is, so that means you need to think about something within 5 units, right, from this point to. So that is how you could actually understand the definition and work on it. And therefore, we have shifted our absolute function 2 units to the right, and we say absolute value of x minus 2, that is shifted 2 units to the right, and we are within 5 units, right? So which is less than 5. Does this make a sense? Right? So I think that makes a sense, correct? Perfect. Now, so this is kind of very important to understand. Let us apply the same principle here and get the answer. So I'll leave that for you for the time being. You can pause the video and do it. But here we have a complication, and that is this part 9.5 is not included. So we may have to write this as two absolute functions. Does make sense to you, right? Since if this was both included, then the solution would have been simpler, just as we did, correct? Okay, let's apply the method at least. So our method number 1, first step is to find the midpoint. So midpoint m will be 0.5 plus 9.5, which is 10, divided by 2 is 5. So we do get a value here, which is for m as 5. Now how much away are we? So the away means this distance between the two is what? So the distance between the two is 9.5 minus 5, which is 4.5. Correct. So that gives you a function which is in absolute terms, we are saying within 4.5 units of 5, right? So we have moved 5 units to the right. So we have x minus 5, right? And within means less than, and then within 4.5, correct? But this does not help us to take care of the point which we have at 0.5, because this means that 0.5 is not included. Do you see that? Correct? Now, so therefore, what we should do? So therefore, what we should do is we could actually also write another inequality and to take care of this point, right? So we say this or you can also say union, right? You could also write union, not intersection, or union. So we'll write another inequality to take care of this 0.5, right? So that will be absolute value of x, and when we take care of this, we can write this as an equation, which is minus 0.5 is equal to 0. So that will give you this point, correct? So we have done it with a combination. So this is a unique example where we had to do this kind of a combination to work out the solution, correct? If we have to write in this way. Perfect. So I hope that makes sense. Slightly more complicated than what I thought of. Anyway, now let's look into the algebraic method, the pure algebraic method, which I'll call this as our method number 2. Now, method 2 is a very popular method to do, and what we are saying here is that when I'm saying that x is within minus 3 and 7, and we want to write this as x minus a less than b, right? We want to write this, right? So basically, think like this. We want to write that x minus a is less than b. That really means that x minus a is less than b, but is greater than minus b. Is that clear to you? That means that x minus a is between minus b and plus b. We can add a and we can write a minus b, and here we get x by adding a, and we get a plus b. So basically our answer always will be, for such inequality, writing it as an inequality will get x between these two values. Correct? A minus b and a plus b. You get an idea, correct? So that is what it is. Now in our case, we are given a minus b, the left side, as minus 3. And a plus b as 7. So basically, what you have here is, well, form an equation and then do the needful. So what we have here is a minus b is equal to minus 3, and a plus b is equal to 7. When you add them, you get 2a equals to, add them, you get 4, and that gives you a equals to 2. Is that clear to you? Right? So if a is 2 and a plus b is 7, so b is 7 minus 2, we get 5. Is that clear to you? Now, we can always write it in this particular form, which is x minus a. That is to say, let me just change the ink and write it as absolute value of x minus a, which is 2 for us, and is less than b, which is 5 for us. Does it make sense to you? So once we understand that the inequality, which is kind of like this, right, can be written as this. Do you get an idea? Correct? Now what I will do here is, we'll not get into this complication. I'll change the question here, and I'll rewrite the question as 0.5 less than equal to x is less than equal to 9.5, right? So let me call this as C. So we'll write the inequality for this particular expression using what we have just learned, right? We want to write this as x minus a is less than, this time it will be less than equal to, right? Since we have used equal to, right? So equal to b. Now from here, we can see very clearly what is a equal to and what is b equal to, right? So what we found here was a minus b. You could again do the same thing, right? Which will involve that the a minus b is the lower bound, which is 0.5, and a plus b is the upper bound, which is 9.5. And when you add them up, you get 2a equals to 10, and then that gives you a as equal to 5. Do you see? Now this is exactly same as our midpoint concept. Do you see that? So that is what we do to find the midpoint. So finding a is kind of finding the midpoint, right? And the value of b is how far are you from a, right? So we know a plus b is 9.5, correct? So we could also write from here that b is equal to, so when you say a plus b is 9.5, so b is 9.5 minus a, which is 5, so b is 4.5. Is that clear to you? So we get both the values of a and b, and 4.5 is basically the distance d which you found here, correct? So let me correlate them so that you understand both the methods very clearly. Correct? And now you can write the answer. We changed the question, remember that, right? So we have now x minus 5 absolute value is less than equal to 4.5. Does it make sense to you? Correct? So that is how, if the inequalities have different limits on the ends, we will do solve a question. I still prefer the very first method which we talked about, since it comes from the very basic definition of absolute function. Find the midpoint and how far are you, right? So these two are two steps to do them, which algebraically means what we have done here. Perfect? Question number 4. Solve the following inequalities. See, absolute value of 3x minus 2 is less than or equal to 4, and absolute value of x minus 4 minus 3 is greater than or equal to 1. So when we have less than or equal to, that means we are talking about this thing within an interval, right? And that interval is bounded by 4 on the upper side and minus 4 on the lower side. Now we can add 2, so we get minus 4 plus 2, and this becomes 3x is less than or equals to 4 plus 2, and that gives you, this is minus 2, let's rewrite, and 6 dividing by 3, we get minus 2 over 3 less than or equals to x 6 over 3, and so we get our solution, which is within minus 2 over 3 and 2. You could always show this solution on a number line, which is not a part of this question. We have solved the inequalities, but you could represent this between, we are saying equal to 2, right? And we are equals to minus 2 over 3, correct? So that becomes a solution for this particular inequality. Now the second one here involves some intricacies. First, it is greater than or equal to, so you have to be careful. Let's rewrite this as x minus 4. Taking 3 to the right side makes it as 1 plus 3, which is 4. Now whenever you have greater than, we're actually looking for values which are outside, right? So we are looking for something which will be kind of like this, right? So that is the approach. So that really means that we have to solve it into two pieces. One piece is when x minus 4 is greater than or equal to 4. The other is when x minus 4 is less than or equal to minus 4. Does it make sense to you? So solving this, we get x is less than or equals to minus 4 plus 4, means x is less than or equal to 0. And on this side, we get x is greater than or equals to 4 plus 4, or x is greater than or equal to 8. So that becomes our solution. So these 2 points which we are looking for were 0 and 8. Does it make sense to you? So that is the easiest way of solving the given question. So I hope you understand and appreciate it. So once you kind of sketch it, you understand that we are going beyond, right? So remember these two things. This is beyond, right? And this is within. Right? Simple things help you perform better. The last question here is, now we are inequalities involving two absolute functions. How should we approach these kinds of questions? I will suggest that you have a combined approach here. So what we will do here is we have a combination of graph plus algebra. That will give you the simplest way of solving this kind of an inequality, right? Now, the method which is sometimes used is when you have, think about it. So if you have absolute value of A, right, and equal to, let's say, absolute value of B, what you normally do is you say that the A square is equals to B square and then solve, right? But that is time consuming and it takes a lot of time. So we'll just see what could be the solution, and then we will solve it. So a graph tells you what could be the solution. So let us sketch this. Half of x, right? Kind of like this. This is not so sharp as this. So half of x means we have an absolute function which is kind of like this. So this is 0.5 x absolute value. Clear? The other function which we are looking into is x minus 4, right? So the other one is x minus 4, means you have moved 4 units to the right, let's say, and now your function has a gradient which is twice as it was for this function, right? So higher gradient. This is your function, which is absolute value of x minus 4, where this value is 4, and here we know it is 0. It does make sense to you. We are looking for 0.5x absolute value greater than x minus 2. So that is possible in this interval. So we are looking for that particular solution. Is that clear to you? What are these 2 points? So clearly what we need to analyze is the right side of this, right? So we are trying to figure out what happens when we are working on the right side of this particular unit. Correct? When we are working on the right side of this, what is really happening? So we need to find these 2 points. Perfect. So that is the concept here. So in the right side of this particular function, we can now deal with a situation. Either way, we could do a square of thing and find the point of intersections and then find the answer, right? Or we could also just do it with linear equations, right? So we'll have now approach with piecewise functions. So if I'm looking at a point which is x is greater than equal to 4, or when x is less than 4, right? So these are the 2 intervals. We know the graph of absolute value of x minus 4 is different, right? So here the 2 inequalities will become that 0.5x is in these intervals, that is the inequality, is greater than negative part of x minus 4. Do you understand? So it is negative part of x minus 4. And on this side, 0.5x is greater than the positive part of x minus 4. Since x minus 4, the absolute value, can be written as a combination of 2 pieces, which is x minus 4 when x is greater than equal to 4, but negative value of x minus 4 when x is less than 4. So we have used this concept to find the answer. So that gives you a solution. This is like half, right? So x is greater than 2 times x minus 4, 8. Just multiply both by 2, right? Or you could do this subtraction. Bringing 8 to this side, we get 2x minus x, or we can say that 8 is greater than x, or x is less than 8. So this point here is 8 for us. You get the idea, right? Now, since it is less than 8, and we are working on an interval from x greater than equal to 4, the solution here is from, let me just show you this solution here on a number line. So on a number line, this solution is indicating that we are looking for x less than 8, right? So less than 8 will include the point 4, and here we have 8. So that part is what we are saying here within this interval. Does it make sense to you? Now let's do this part. Let me rewrite this as half of x, as 0.5 can be written, right, is greater than minus x plus 4. Bringing this on the other side, we get x plus half of x is greater than 4, right? So which is 3 by 2. 3 by 2 of x is greater than 4. And that gives you that x is greater than 4 times 2 by 3, which is 8 by 3, right? So we get x, less spaces here. Okay. So we get x is greater than 8 by 3. Perfect. So on this side, when we're talking about less than 4, we have a value of x which is greater than 8 by 3. So this point here will be 8 by 3 for us. So this point here is 8 by 3. Do you see that? So we get our solution, and the answer in this particular case is going to be that the value of x is less than 8 but is greater than 8 by 3. So it's kind of tricky, but we have avoided squaring and then working with the quadratic equation. So I hope you understand and appreciate that part. And in this way, it is different from normal solutions. Well, let's take another example, and I think that will make it absolutely clear. Now we are talking about solving inequality which has two absolute values as we had last time, right? However, both of them have same gradient almost, right? 1 or minus 1. So the first one is x minus 4. So let me just sketch this first one, x minus 4 here. So that is the absolute value of x minus 4, right? So where this point is 4. The second one here is x plus 3. So somewhere here we have this. Well, this is not an accurate graph, but we know these two lines are parallel, right? Now, since we know that, we know there is only one point of intersection, and we are actually looking for this point of intersection. We don't know where this is. But we know one thing, it falls on the right side of this, right, when x is greater than minus 3, and it is on the left side when x is less than 4. Is that clear to you? So that means we have to only solve one inequality, right? And that inequality should be solved within this interval, correct? This point here is minus 3 for you, correct? So in that case, if we are talking about x greater than minus 3, then the absolute value of x plus 3, could be written as x plus 3. For x greater than equal to minus 3, it is negative of x plus 3 for x less than minus 3. As far as the other inequality goes, which is absolute value of x minus 4, it is positive for x greater than equal to 4, but it is negative, eliminate negative here, for x less than 4, correct? So since we are looking into these parts now, we'll solve the inequality based on these values. So I could actually solve for, when we say absolute value of x plus 3 is less than equal to absolute value of x minus 4, I can take this right side, correct, which is x plus 3, is less than equal to the left side, which is minus of x minus 4. Does it make sense to you? This is the most critical part, right? So let's open the bracket and solve. So we x plus 3 is less than equal to minus x plus 4. Bring it on this side. So x plus x is less than equals to 4 minus 3. 2x is less than equals to 1. X is less than equal to half. Correct? So that becomes the solution. So we got this point which is at half. So this is right side. So basically this point is at x equals to half. Does make sense to you, right? Now we want this part to be less than, right? So when is it less than? It is less than on the left side of half, as you can see. So we do have an answer here. So it is on a number line, it will be less than equal to this point, correct, which is at half. So we have our answer, and that is x is less than equal to half. Does make sense to you? So this solution which I have provided you here is an ultimate simplified way of solving such inequalities. I hope you understand and appreciate it. It's kind of tricky, but it comes with practice and understanding completely what absolute functions are, right? What is a modulus value? Perfect. Once you understand this, this should not be a difficult issue, right? So on a number line, you can always represent this information as a value to the left side of half. Is that clear to you? I hope it makes sense. So with that, we conclude our video on inequalities of absolute functions. I hope that was a good learning experience. Feel free to write your comments, share your views. You can always subscribe and post your questions. We are always there to provide you with some suggestions. Thanks for your time and all the best.